Good morning, dear students. My name is Ferhan Mazher, and today is 10th of September 2021. Right now, I am with the 9 Matric class. The subjects we are studying is physics. We are on the second chapter. We have finished this chapter. Kinematics is the name of the chapter, and we are working on its numericals. We have already solved 2.1, 2.2, and 2.3 numerical, and today we will start working from the question number 2.4. So let's start. The question number 2.4 is showing up on your screen. Hopefully you can see that. A tennis ball is hit vertically upward with a velocity of 30 meter per second. It takes 3 seconds to reach the highest point. Calculate the maximum height reached by the ball. How long it will take to return to the ground. Before you solve this question, one thing you should understand is that when anything goes upward, when anything is projected upward, at the start, the initial velocity will be maximum. As the thing will go up, the velocity will decrease. Gradually, the velocity will decrease. When the ball will reach, or any projectile will reach at its maximum height, the velocity will become zero. For example, here the tennis ball, when hit vertically upward, the initial velocity was 30 meter per second. When you launched, when you projected that tennis ball in upward, when you throw that tennis ball upward, the initial velocity is 30 meter per second. But when the ball will reach its maximum height, the velocity will become zero. That is very important fact about the projectiles which go vertically upward. So at the maximum height, their velocity becomes zero. There the body stops for a moment and then it comes back. For example, you throw a ball, it goes up, it stops there, then it comes back. So when you are considering the portion of the motion in which the body is going upward, the initial velocity when you launch it is 30 meter per second, and when it will reach its maximum height, the final velocity will be zero. It says it takes 3 seconds to reach the highest point. So the initial velocity is 30 meter per second, the final velocity is 0 meter per second, time is 3 seconds, the g value, the acceleration is minus 10, because when you go upward, the acceleration will be equals to g, with whose value is 10. Because you are going upward against the gravity, the g value will be acting like a deceleration, so its numerical value will be minus 10. Let me show you how this is done. Let me show you. Let's do this. Okay, G. Let me show you how this is done. Okay. So on your screen, hopefully this is showing up, and let me increase the size. Okay, this is question number 2.4, numerical 2.4. Okay, so on your screen, this is showing the initial velocity when the ball is projected upward is 30 meter per second. From our knowledge, we know that the final velocity at the highest point is always 0 meter per second. The time taken from ground to reach the the maximum height is 3 seconds. Their question is how much height it got. So, you know, the second equation of motion is the distance is equals to VIT plus half AT square. So because we are moving vertically, so I will say H is equals to VIT plus half GT square. In the place of acceleration, I put small g, and in the place of distance, which we represent by S, H is represented because you are going vertically upward. So the height is equals to VI is 30, the time is 3, 1 by 2, the G value, because you are going upward, the value of the acceleration should be taken as negative G. Its value is minus 10. And then T square, that's 3 square. So H will be equals to 30 multiply 3, that will give you 90, 1 by 2. And when you do it on the calculator, it will give you 5 into 9. So 90 minus 45, H will be equals to 45 meter. So the height, the maximum height the ball will attain is 45 meter. The maximum height obtained will be 45 meter. And then the second question they asked is the next question they ask is, look at here, they ask you another question. How long it will take to return to the ground? Remember this, the motion is symmetry. The motion has symmetry. The time it takes to go up, the same time it takes to come back. When you throw something vertically upward, the time the ball takes to go up, the same time it takes to come back to the ground. So if it took 3 seconds to go up, it will take 3 seconds to come back. So the total time taken will be 3 plus 3, that will be 6 seconds. So let me show you. I have shown that there. So you can see the total time taken will be 3 plus 3 equals to 6 seconds. So these are the two questions in 2.4 they ask you. Okay, another very important thing that I have shown here, a speed time graph. And this speed time graph is about this tennis ball, and you can see that here on the y-axis I have represented the velocity, and this is the x-axis. On the x-axis we have represented time, and you can see when you launch, when the time was 0, the speed of the your object was 30 meter per second, and after 3 seconds it reached the maximum height, the velocity became 0, and then the ball started falling downward. When the ball started falling downward, the velocity will become, if you consider going up as positive, then coming down will be negative. Then the velocity will increase, but the sign of the velocity will be different. At 6 seconds, it will touch the ground. When it will touch the ground, all of a sudden the velocity will become 0. So it's very important that you understand that we can represent this motion on a speed time graph also. In your syllabus, mostly we are working with we are solving the questions with the help of the equations. But if we make the speed time graph, then it's very, very easy to solve them. But most people in Matric, they solve the questions with the help of equations. So this is question number 2.4. I hope that you have understood. What you say? Do you understand this?
Yes.
Okay. You don't need to note it down because I will share the slide. This power, I have this thing. I will share it with you. Okay, so you don't need to be bothered about quickly writing. Okay, just understand. Okay, so we are going to the next question. The next question is question number 2.5. Increase the size so you can see. So question number 2.5 is showing up on your screen. A car moves with uniform velocity of 40 meter per second for 5 seconds. It comes to rest in the next 10 seconds with uniform deceleration. Find deceleration. And the second question they are asking is total distance traveled by the car. So try to understand. In the first 5 seconds, the car is moving with the constant speed. The car is moving with the speed of 40 meter per second. For 5 seconds, it moved with the constant speed. Then it decelerated uniformly, and in 10 seconds, in the next 10 seconds, it became to rest. It came to rest, sorry. And came to rest means the velocity became 0. Okay, so there are clearly two portions of this case. In one portion, the car is moving with a constant speed, and then in the next portion, the car is moving with a constant or uniform deceleration. When we have uniform deceleration, the speed is gradually decreasing. Okay, now we have to do this. Let me show you how I have done this. I will try to explain to you how we have done this. Okay, so here we go. Let me increase the size. Okay. So, you can see here, first of all, before we go into solving this question, here I have represented that motion on a speed time graph. Speed time graph means that on the y-axis I have represented the speed, and on the x-axis I have represented the time. So at the start the speed is 40. 40. He says 40. For 5 seconds it continued moving with the uniform speed. So that's why you see this graph is horizontal for 5 seconds. And in the next 10 seconds, it decelerated and came to rest. Means final velocity became zero in the next 10 seconds. So after 5-10 seconds, if you take, it will be 15 seconds. Yeah. So this is how you represent it on a speed time graph. Now, their first question is what is the deceleration? They want you to find out the deceleration here. Here, the deceleration. So the initial velocity in this portion is 40. The final velocity in this portion is 0. The time taken for this change is 10 seconds from 5 to 15. 10 seconds. So acceleration is question. Acceleration is question. Initial velocity is 40 meter per second. The final velocity is 0 meter per second. The time taken is 10 seconds. Their question is what is the acceleration? The acceleration, the famous formula, the first equation of motion. And acceleration is change in velocity divided by time. Vf minus vi divided by time, as you can see on your screen. Vf minus vi divided by time. Vf is 0. The final velocity is 0. The initial velocity here is 40. And the time taken for this change is 10. So minus 40 divided by 10, it will give you minus 4 meter per second square. That was the first question. Then they ask us that what is the total distance traveled? What is the total distance traveled? Okay. So first I will solve it with the help of the equations. Then I will show you how this is done with the graph. In the first portion, you can see the body for 5 seconds is moving with the constant or uniform speed. If the body moves with the uniform speed, you can apply the formula that distance is equal to speed multiplied time. This formula is only applicable if the body is moving with the constant speed, with the uniform speed. Then you can apply this formula, distance is equal to speed multiplied time. So in the first 5 seconds, the body was moving with the constant speed, with the uniform speed. So I can apply this formula. So speed, distance is equal distance 1. I'm saying distance 1, the first portion, distance 1. Speed multiplied time, that will be 40 multiplied 5, that will give you 200 meter. So the distance traveled will be 200 meter. In the second portion, here the velocity is not uniform. Velocity is changing, it's gradually decreasing. So I have to apply the equations of motion. The second equation of motion, I have applied here second equation of motion because I know the value of the deceleration. I know the time taken for the second portion. I know the initial velocity in the second portion. So S is equals to VIT plus half AT square. That's the second equation of motion. Initial velocity 40. Here you can see in this portion, the initial velocity is 40. The time taken in this portion is 10. 1 by 2. The acceleration value is minus 4 for this portion. The deceleration was minus 4. And the t value is 10 and square. Just as it's the game of calculator now. 400 minus this will give you 200. 400 minus 200, that will be 200 meter. So the total distance traveled will be the distance traveled in the first portion plus distance traveled in the second portion. So that will be 200 plus 200, that will give you 400. So that's how you do this question with the help of equations. Now I want to do another thing. The distance traveled, we can calculate directly from the speed time graph. This velocity time graph, speed time graph, the area under the speed time graph, the area under the velocity time graph is equals to the distance traveled. For example, you can look at this diagram. The area I have shown is with the dots. The area under the speed time graph is in the shape of a trapezium. And the formula, if I want to find out this area, the formula of the area of the trapezium is 1 by 2 into height into sum of parallel sides. So the height of the trapezium is 40. And these are the two parallel sides. One parallel side is of 15 seconds, and this is the second parallel side. the parallel sides to each other in the trapezium, that is of 5 seconds. So the formula is 1 by 2 into h into the sum of parallel sides. So 1 by 2 into 40 and sum of 15 and 5. So this you will get 400 meter. This is the second method to find out the distance traveled. You can find out the distance traveled directly from the graph. If you have drawn the graph of speed time graph of that motion, the area under the speed time graph will be equals to the distance traveled. So that was the question number 2.5. What you say? Do you understand?
Yes.
Okay. They are little heavy questions. I know that. But we have to do. They're not that easy, even to understand them. They are heavy. Okay, the question number 2.6 showing up on your screen. A train starts from rest with an acceleration of 0.5 meter per second square. Find its speed in kilometer per hour square. Uh, it has gone wrong. It should be kilometer per hour. When it has moved through 100 meters. Okay, so we are talking about a train which starts from rest. So its initial velocity will be zero because it started from rest. The initial velocity vi will be zero. Its acceleration is given. The value of the a acceleration is 0.5 meter per second. The distance traveled by the train is given, that is 100 meter. And then they say find the final speed. Okay, we have to tell how much the final speed will be. VF is question, very easy question. Let me show you. Okay, question number 2.6 is now we are doing. Okay, so here we go. Question number 2.6 is showing up on your screen. The initial velocity is, the train started from rest. The initial velocity is 0 meter per second. The acceleration value is given 0.5 meter per second square. The distance traveled during that motion is 100 meter, and the final velocity is questioned. And they ask us to represent the final velocity in kilometer per hour. That's the main question. Okay. So the distance is given, the initial velocity is given, the final velocity is questioned, the acceleration is given. We will use the third equation of motion. The third equation of motion is 2as is equals to vf square minus vi square. 2as is equals to vf square minus vi square. 2 and the acceleration value, the value of the acceleration. Hello. So the value of the acceleration is 0.5 and the s value is 100 and equals to vf square minus 0 square. So 2 multiply 0.5 multiply 100, it will give you 100 equals to vf square. Take square root on both the sides. Take square root or under root on both the sides. So vf will be equals to 10 meter per second. Vf will be equals to 10 meter per second. But their question is find the final velocity, but the units, they say kilometer per hour. They want you to represent the final velocity in kilometers per hour. So if you want to convert meter per second into kilometer per hour, you have to multiply with 3600 and divide with 1000. Why multiply 3600? Because in 1 hour there are 3600 seconds. And why divide with 1000? Because in 1 kilometer there are 1000 meters. So if you want to convert 10 meter per second into kilometer per hour, you will multiply with 3600 and divide with 1000. So the final answer will be 36 kilometer per hour. What do you say? Do you understand?
Yes.
Yes. Good. So this was the question number 2.6. So let's move to the next question. Okay. The next one is 2.7. Okay. So question number 2.7 is showing up on your screen. A train starting from rest. So the initial velocity is 0. Accelerates uniformly and attains a velocity of 48 kilometer per hour in 2 minutes. So its velocity was gradually uniform, with the uniform acceleration was increasing. So the final velocity is 48 kilometer per hour, and this happened in 2 minutes. In 2 minutes, the velocity from 0 went to 48 kilometer per hour in 2 minutes. Okay. It travels at this speed for 5 minutes. So now he's talking about another portion of the travel. He says it continued traveling with that speed, 48 kilometer per hour, for 5 minutes. Finally, this is the third portion. Finally, it moves with uniform retardation and is stopped after 3 minutes. Then its speed started gradually decreasing, and in 3 minutes it came to rest. So this is the third portion of the motion. Find the total distance traveled by the train. See, try to understand. Let me show you. Then it will be easier for you to understand. Mm, mm, okay, where is that? You see this? Can you see this? No, we can. No. I have represented here the motion. Before you start solving it, just try to understand. There are three portions of that motion. In the first portion, the train was at rest. It started in the next 2 minutes. Its speed started increasing. And in the 2 minutes, what happened? The speed became 48 kilometer per hour. Okay? In 2 minutes. And I think this is not. No. I just want to show you. Let me show you a bigger, a more. The diagram is, I want that to be big. Okay, now it's good. Okay, now you can see that the train started from rest. In 2 minutes. The speed became 48 kilometer per hour. Then in the next 5 seconds, the train moved with that speed, 48 kilometer per hour. Okay, this speed. And then in the next 3 minutes, I said seconds, I think it's 5 minutes. Okay, in the next 3 minutes, the train speed decreased and it became 0. Okay, so that is the motion. Three portions of that motion. So their question is find the total distance traveled. So I will find out the distance traveled in this portion, the distance traveled in this portion, and distance traveled in this portion. So let me talk about this section number 1. In the section number 1, you see here, for first of all, one thing is very important. The way I have done this, I converted that 48 kilometer per hour into meter per second. So how you convert it? You multiply it with 1000 and you divide it with 3600. So the kilometer per hour will be converted into meter per second. So when I multiply 48 with 1000 and divide it with 3600, to convert from kilometer per hour to meter per second, it becomes 13.33 meter per second. You can see here you can see we have done that conversion. Okay. So 48 multiply 1000 divided by 3600, it will be converted from kilometer per hour to meter per second. Now, I'm going to apply equation of motion on this first portion. The initial velocity in this portion is 0. The final velocity is 48 kilometer per hour, which in meter per second is 13.33. The time taken for this is 2 minutes. But now I'm not going to take the time in minutes. The time taken will be 120 seconds. The time taken for this first portion is in minutes, 2 minutes, but I will convert it into seconds. In 1 minute, there are 60 seconds. So 2 minutes means 120 seconds. The main question is what is the distance traveled? Okay. So first of all, for this portion, I will find out what is the acceleration. The value of the acceleration is Vf minus Vi divided by T. Vf is 13.33, Vi is 0, time taken is 120. So the value of the acceleration will be 0.111 meter per second square. You apply that formula, S is equals to VIT plus 1 by 2 AT square, second equation of motion. Vi is 0, T is 120 plus 1 by 2, A value is 0.111 and the bracket T value is 120, so it's square. Just enter these things in the calculator, you will get 799.2. It's approximately 800. It's approximately 800 because the calculator is saying 7.99.2 meters, so it's approximately 800 meters. So that is how you find the distance traveled in the first portion. In the first portion, the initial velocity was 0. The final velocity was 13.33 meter per second, and this took 120 seconds. So first of all, I calculated what is the acceleration. Then I applied the second equation of motion, S is equals to VAT plus half AT square, and I found the distance traveled in the first portion. Now the distance traveled in this second portion, I will use the quadratic. You see here, the train is moving with the uniform speed. And I told you that if a body moves with a uniform speed, then you can apply that formula, distance is equals to speed multiplied time. If the body is moving with a constant speed, then you can apply in that portion the formulas, distance is equals to speed multiplied time. Otherwise, you cannot use that formula. So in the second section of this motion, the train is moving with the constant speed. So you can apply this formula. So you see in the second portion, the velocity with which the train is moving, the constant velocity, that is 13.33 meter per second. And for 5 minutes, the train moved with that constant speed. So 5 minutes in seconds, in 1 minute we have 60 seconds, in 5 minutes we will have 300 seconds. So in the second portion, the distance traveled will be velocity multiplied time. That will be 13.33 multiplied 300 equals to, so that is 3999 meters. That is approximately 4,000 meters. Okay. Oh. Okay. So that was the section number, second section. You see this second section? We have found the distance traveled here. Then we have this third section. Look at this third section. In this third section, the initial velocity will be 13.33. The final velocity will be 0. And the time taken here will be 3 minutes. And I will convert that 3 minutes into seconds. You see here. You see here, section number 3, the initial velocity is 13.33 meter per second. The final velocity is 0 meter per second. The time taken is 3 minutes, which is 180 seconds. What is the how much is the distance traveled? First of all, I will find out the value of the deceleration in this portion. The formula, first equation of motion, A is equals to Vf minus Vi divided by T. The final velocity is 0. The initial velocity is 13.33 and the time taken is 180 seconds. So the answer will be 0.0741 meter per second square. So that's the value of the deceleration. Okay. Now I will apply the second equation of motion to find out the distance traveled. S is equals to VIT plus 1 by 2 AT square. Vi is 13.33. time is 180, 1 by plus 1 by 2 into a value is minus 0.0741, and the t value is 180 and its square. So you do this calculation and the final answer will come out to be 1198.98. So it will be approximately 1200 meter. It will be approximately 1200 meter. Now we have found the distance traveled in the three portions. So the total distance traveled will be the S1 plus S2 plus S3, the distance in the first section, the distance traveled in the second section, the distance traveled in the third section. You just add them up and that will give you the total distance traveled. So here you have, you just add these three, S1, S2, S3, and that the because of the calculator, my answer came to be 5997.18. Approximately it will be 6,000 meters, the answer which was given in your book. Okay, so this is one style of doing this question, and another way of doing this question I can tell you is another method of getting the distance traveled is to find out that distance traveled from the graph. This way is in your book. Most of the Matric people do like this, but you can you can find out the distance traveled by this train very simply. You have this speed time graph, this speed time graph. Here is the second method done. This speed time graph is shown here. You know the shape of this graph. The total distance traveled will be equal to the area under the speed time graph. This is a trapezium. I can find its area very easily. 1 by 2 into height into sum of parallel sides. The height here is 48 kilometer per hour. So I will convert it into meter per second. So that will be 13.33. But I have done here. Okay, let's go with the kilometers. So that is 48 kilometer per hour. The time here is this portion. This parallel side is 10 minute. I will convert the minute into hours. And this side, this is 5 minutes. I will convert it into hours. Okay, because its unit is kilometer per hour. So the time here must be in hours. So 10 divided by 60 plus 5 divided by 60. So that will be 15 divided by 60, and this will be 24 and 6 kilometers. And 6 kilometers mean 6,000 meters. That's the second method in which you can find out the distance traveled directly by finding the area under the speed time graph. In Matric, mostly people apply equations of motion to get the distance traveled. Showing up on your screen, and I hope that it's
Yes, sir.
hello.
Yes.
Yes. Okay. So they are. I understand. Questions are a little. So it takes if when you practice them and you actually get the concept, then they are very easy. Only 3 or 4 equations are being used here, and you just have to understand what the story is. A cricket ball is hit vertically upward and returns to the ground 6 seconds later. Calculate the maximum height reached by the ball, initial velocity of the ball. Okay, you see that the ball went up and then came back, and it took 6 seconds. I told you that this vertical motion of going upward and coming back, it's symmetrical. It has symmetry in going up and coming back. The time it takes to go up, the same time it takes to come back. So if the total time of going up and coming down is 6 seconds, then the time taken for going up only will be 3 seconds. If it takes 6 seconds to go up and come back, then if you consider only one portion in which the ball went to the highest point from the ground, that will take 3 seconds. Okay. So when you launch the ball, the initial velocity will be maximum. I don't know how much. That's the question to us. And the final velocity, and it will take 3 seconds. The value of the acceleration will be Small g, because you are going vertically upward against the gravity, the value of the acceleration will be small g and its value will be minus 10 meter per second square. The final velocity will be zero. Whenever something is launched, when it reaches its maximum height, the velocity at the maximum height becomes zero. And then it comes back. So when you launched it upward, the initial velocity we have to calculate. The time taken is 3 seconds. The acceleration value is minus 10 meter per second square. The final velocity will be definitely zero. So very easy, by applying the first equation of motion, I can find out the initial velocity. Let me show you my work. Okay. Okay. Here we go. So, in the first portion of the motion, when the ball goes up, the final velocity will be zero. Initial velocity is question. The g value, the acceleration value, will be minus 10 meter per second square. Because you are going against the gravity, your speed is gradually decreasing. The time taken in going up will be 3 seconds. The question is, what will be the final velocity? The first equation of motion, Vf is equals to Vi plus Gt. And if you want to find out the vi, if you make the vi subject of the formula, the gt will go on the other side, it will be subtracted. So vi equals to vf minus gt. Put the values there. Vf is 0, minus g value is minus 10, and the t value is 3. As will become positive 3 into 10, that will be 30 meter per second. So the initial velocity with which the tennis ball was launched upward, and that is 30 meter per second. And then they ask you a question that how much is the height attained. You see, if you consider this portion in which it went up, the initial velocity is 30 meter per second. The time taken in going upward is 3 seconds. The g value or the acceleration value is minus 10. You just put these values into the second equation of motion. S is equals to VIT plus half 80 square. So Vi is 30, T is 3 plus 1 by 2, G value is minus 10, T value is 3, its square. So S will be equals to, just do the calculation. That 30 into 3, that's 90, and you do this calculation. This is a square, okay? 1 by 2 multiply 10 multiply 3 square, that will give you 45, and a negative here. So 90 minus 45, that will be 45. So the ball went up how much? 45 meter. The maximum height the ball attained is 45 meter. Here I have tried to show the motion of the ball on the speed time graph. When you launched it, the speed will be something like 30 meter per second. We just calculated. And when it will reach after 3 seconds to the maximum height, the velocity will become zero. And then the direction of the velocity will change and the ball will come down. So the velocity will increase, but its sign will be different. Sign different means it is moving in the opposite direction. If you consider the going upward as a positive, then coming downward will be negative. So you don't have to be bothered about this, and we make this for our understanding. They make the question easier, but in Matric, basically we solve the question with the help of equations. So this is the question number 2.8. So what you say? Do you understand this? Mehani says yes.
Yes.
Okay. Thank you. Thank you. So we are going to the next question. The next question is, because we have 2 lessons today, so I am continuously working on it. So we will do the 2.9, 2.10, and then you are free. Okay. So when brakes are applied, this is the question number 2.9. He says when the brakes are applied, the speed of a train decreases from 96 kilometer per hour to 40 kilometer per hour in 800 meter. So during this, the train covered 800 meter. How much further will the train move before coming to rest? So how much more distance the train will cover before its velocity becomes 0 kilometer per hour? Assuming the retardation to be constant. He says that during this whole motion, the retardation value, the deceleration value, the acceleration value will be same. Okay. So initially the car was at 96 kilometer per hour, and its speed is decreasing gradually. So when it has covered 800 meter, its speed has decreased from 96 kilometer to 48 kilometer per hour. So we have to tell how much further, how much distance will be covered before the train comes to rest. Okay, by the train, when the train will come to rest, how much distance it had covered. So that's the question. So let me go to the next question. Okay, here I have done it purely with the help of equations. So that this is question number 2.9 coming up on your screen. Okay. So in the first portion of the motion, the initial velocity is 96 kilometer per hour, and the final velocity is 48 kilometer per hour. During this, the train covered 800 meter. So one thing is, this is my style. I converted it into meter per second. So 96 kilometer per hour, if you want to convert it into meter per second, what you will do, you will multiply it with 1000 and divide it with 3600. So it will be converted into meter per second. So you can see here, I have multiplied it. 96 multiplied 1000 divided by 3600, it gives you 26.67 meter per second. And this final velocity was 48 kilometer per hour. I will convert this into meter per second. I multiplied it with 48 multiplied 1000 divided by 3600. So that will be 13.33 meter per second. The distance traveled is 800 meter. Now I will apply the third equation of motion. 2as is equals to vf square minus vi square. 2as is equals to vf square minus vi square. So you see here, 2 multiply the a value I want to find out, 800, distance traveled is 800. The final velocity is 13.33 square minus initial velocity is 26.67 and it's square. So just do this calculation. You got this, you got this. From this, subtract this, you get this. This 1600 will go to the other side, it will divide. So the deceleration value will be 0.33345 meter per second square. So the deceleration value when the speed decreased from 96 to 48 and the train covered 800 meter, during this the value of the deceleration in meter per second square is 0.333. That's the that is the the deceleration. Okay. Now their actual question is that how much further it will go. Okay. So the initial, now we are talking about the second portion. Here the speed will go from 48 kilometer per hour to 0. So here in the second portion, the speed is, initial velocity is 48 kilometer per hour, and in meter per second it will be 13.33 meter per second. The final velocity will be 0 meter per second. The deceleration value we already know, that is 0.333345 meter per second square. How much distance will be traveled? So you have 2as is equals, that's the third equation of motion, 2as is equals to vf square minus vi square. In this portion of the motion, 2 is 2, the deceleration value is as the previous value, minus 0.345. S value I want to find out, the distance traveled. The final velocity I want is 0. The train should come to rest. And the initial velocity here is, I just made a mistake here a little bit. So that is 13.33 and it's square. Just do the calculation. 2 multiply this minus 0.6690, and S will remain as this 0 is 0, just neglect it. And this 13.3 square will be a minus here, minus 177.689. This minus and minus will be cancelled. This 0.6690, which is multiplying here with the S, that will go on the other side and it will divide there. So you will have 177.689 divided by 0.6690. So the final answer will be 266.6 meter. So the train will further, how much the train will further move? It will move 266.6 meters. So this is the question, numerical number 2.9. And after this, we have the last numerical of this chapter. Yes, Bete, what you say? Is this little bit clear?
Yes.
So we are moving to the next question. The next question is question number 10, is showing up on your screen. He says, in the above problem, the question number 2.9, find the time taken by the train to stop after the application of the brakes. So this question is related with the question number 2.9. So initial velocity of the train was 96 kilometer per hour, and you applied the brakes, and the velocity became zero. So during this whole process, his question is, how much is the time taken? This is the question number 2.10. Okay. So how much is the time taken during this? So let me show you my work. Okay, better. So here we go. So question number 2. Initial velocity is 96 kilometers per hour. The final velocity is 0 meter per second. I have shown here that I converted the kilometer per hour into meter per second. And in meter per second, you know how you do this. You multiply with 1000, you divide it with 3600, and the meter per second, this velocity will be 26.67. The final velocity is 0 meter per second. The value of the deceleration we already know in the previous question, that the value of the deceleration will be minus 0.3345 meter per second square. Their question is how much time it will take from the velocity to change from 96 kilometer per hour to 0 kilometer per hour. Time taken is question. Apply the first equation of motion. Vf is equals to Vi plus At. Vf is 0. Vi is 26.67 meter per second. The value of the A is 0.333 meter per second square. The T value is question. Okay, take this whole thing, because it's negative, take it to the other side. So it will be 0.3345 T equals to 26.67. Take this 0.3345 to this side, and T will be equals to 79.98. This is approximately 80 seconds. So that's approximately 80 seconds. So this is question number 2.10. So hopefully you have understood. Okay. So these were the numericals of the chapter number. Chapter number. We were solving the numericals related with the chapter number 2. The name of the chapter is Kinematics, and this is physics of 9 metric. So we are done with the numericals, and I think this is enough for today. We need to take a break, and then I will check if yes, you have to do them on your copy. It's very important. You do them, and also one very important thing: do the examples also which are in the book. Okay, they can also come in your papers. So I think enough for today. So thank you very much, everybody, and don't go away because I want to take your attendance. So thank you very much, because I will be stopping the recording. So it was a pleasure teaching you all. Thank you very much. Have a good day. God bless you all.